Back, problem 4, section 1-4. A ball is thrown into the air by a baby alien on a planet in the system of Alpha Centauri with a velocity of 38 feet per second. Its height in feet after t seconds is given by this formula. So that is y coordinate given any t coordinate. T is time. There is no x coordinate here. We have t versus y. All right, find the average velocity. Average velocity is nothing but slope. Okay, average velocity is slope. Instantaneous velocity is the limit. Okay, so average velocity geometrically is slope of the secant. Instant velocity is slope of the tangent. Slope of the tangent is limit of the slopes of the secants. So you have to find these average velocities and see what those numbers approach. That approached number is the instantaneous velocity. So remember this terminology. Instantaneous velocity is limit. Average velocity is slope between 2 points. All right. Now when t is 3, what is y? Well, let's see. T is 3. What is y? Y is 38 times 3 minus 25 times 3 power 2. That's y. Do I have to calculate it? I don't. So that is my first point. T coordinate and y coordinate. All right. So what is the second point? Well, second point will change as time changes. So you're beginning at time t equals 3 and lasting 0.01 seconds. Lasting means you have to, starting at 3, go 0.01 second more. So the new t is, all right, the new t is the second t is 3.01. So what is the second y? It is, well, 38 times 3.01 minus 25 times 3.01 power 2. Okay, so that's the, so you have 2 points. This is second point, that's first point. So for good measure, let me call it first point t coordinates, first point y coordinate. All right. So what is the slope then? So slope is, in this case, y2 minus y1 over x2 minus x1. So it's a fraction. Numerator is y2, that's complicated, and y1 there, that's also complicated. So let me write 2 parentheses for numerator. Okay, because they are complicated pictures, so, and you're subtracting, so it's better to write parentheses. All right, so 38 times 3.01 minus 25 times 3.01 power 2. Okay, so that's the y2. Now y1 coordinate is 38 times 3 minus 25 times 3 power 2. Okay, let me move it here. Denominator is t2 minus t1, 3.01 minus 3. Okay, now I'm going to put that, so that's my slope, which is average velocity. Now you notice this expression is very complicated. So I will write parenthesis for denominator and a big parenthesis for the numerator. Okay, so write down. All right, numerator divided by denominator. Denominator is a simple one, so I'll go through that first. 3.01 minus 3. Numerator is a complicated piece. So if you remember, the numerator itself had a minus and a parenthesis minus parenthesis. We did this because subtraction of an expression, we have to be very careful. So all right, so the first parenthesis is 38 times 3.01 minus 25 times 3.01 power 2. Power is hat. Okay, hat is right above 6 if you notice. So next, this subtract the other one. 38 times 3 minus 25 times 3 power 2. All right, so that completes that expression. The second one is t starting at 3 going for 0.005. So instead of 0.01, you have 0.005. That's all. So I'll copy this expression, and where I see 0.01, I'll replace it by 0.005 because that's what this is. Instead of 3.01, it's going to be 3.005. So wherever I see 3.01, I replace it by 3.005. 3.005. All right. Likewise, 3.002. 002. All right. 002. Okay. Try not to use your calculator and find an approximation because your approximation WebWork might not like. The last one, 001. 001. 001. And 001. All right. So these are the various average velocities. We want to see what they approach. So the expression looks exactly how you want it. Huge numerator, denominator, and they are all correct. So look at that. What does it look like? It seems I am approaching negative 112 point, let's say 0. We don't know. I'm guessing. I'm seeing what it looks like, right? So it started with 0.25, 0.125, 0.05, 0.025. So it's getting smaller and smaller. So let's say 0.0. That's possibly my approached value, and it's accepted. Okay. So the limit is called instantaneous velocity, whereas the actual averages, the actual slopes with 2 points, they are called average velocities. Okay. So next problem, we'll get back to you in the next video. Until then.